The Arabian Sea at 3:19 a.m. holds a specific quality of silence that experienced watchstanders learn to distrust. It is not the silence of an empty ocean. It is the silence of an ocean that has too many variables in it to produce a clear signal. The background clutter of commercial shipping lanes, the electronic emissions of a dozen coastal nations conducting their nightly business, the atmospheric ducting effects that bend radar returns in unpredictable geometries and make the horizon a negotiable concept rather than a fixed line. USS Lake Erie had been operating in that silence for 11 hours, holding a barrier position 140 kilometers south of the Iranian coastline, while the intelligence package that had brought her here was refined, updated, and twice revised by the watch team in the Combat Information Center. The package concerned a convoy, not a military convoy in any formal sense. 3 fishing vessels and 1 mid-sized general cargo dhow, all flying flags of convenience, all with transponder histories that the intelligence analysts had described as deliberately inconsistent. Vessels that appeared on tracking systems when it was convenient for them to appear, and disappeared from those systems when it was not. The cargo intelligence assessment was the result of 11 days of collection that had combined signals intercepts, imagery analysis, and a human source report whose reliability the collection managers had rated as moderate, but whose specificity had been striking. The vessels were carrying components for a ballistic missile guidance system that had been developed under a program that the Iranian Aerospace Industries Organization had been running since 2021, and the destination was a port on the Yemeni coast, where the assembly infrastructure had been identified in overhead imagery taken 6 weeks earlier. The interdiction authority had been granted at the fleet commander level, after a legal review that had taken 48 hours and produced a 14-page authorization document that the Lake Erie's operations officer had read once in full, and then reduced to 3 operational sentences: approach, assert, board. The boarding teams had been rehearsed. The legal authority was documented. The operation had the geometry of procedure. What the operations officer had not incorporated into that procedure was the 11 hours that had elapsed between the authorization and the current moment, during which the convoy had altered its course twice in ways that extended the intercept timeline, and during which the intelligence picture had been updated with a data point that he had flagged in his watch log. A signals intercept from 2 hours earlier indicating coordination between the convoy lead vessel and a maritime liaison node ashore whose communication patterns had previously been associated with IRGC Navy operational support. The convoy knew it was being tracked. It was maintaining a compressed formation and a reduced speed that had no logical explanation in terms of normal maritime operations, and a clear explanation in terms of a vessel waiting for an escort asset to be repositioned to cover it. The operations officer had included that assessment in his last update to the fleet commander. The fleet commander had maintained the interdiction order. In the 40 minutes since that update, the nature of the escort asset had begun to clarify itself on the Lake Erie's electronic warfare display. What the procedure had not fully accounted for was the Iranian Air Force. The Islamic Republic of Iran Air Force operates a fleet of F-14 Tomcat fighters that it has maintained, modified, and kept operationally relevant since their acquisition before the revolution through a domestic sustainment program that Western analysts had consistently rated as impressive given the complete absence of manufacturer support for over 4 decades. The aircraft are not what they were when they were delivered. They have been through maintenance cycles that have substituted domestic components for unavailable American originals, modifications that have addressed airframe fatigue through solutions that would not have passed a U.S. Navy airworthiness review, and weapons integration programs that have replaced the original AIM-54 Phoenix missile, long since depleted, with the domestically developed Fakor 90, a long-range air-to-air missile derived from the Phoenix's design, but incorporating Iranian modifications to the seeker head, propulsion, and guidance architecture. The Fakor 90 is not a precise replica of the weapon it replaced. It is a derivative, and derivatives carry the characteristics of their lineage imperfectly. What it retains from the Phoenix is the fundamental engagement concept, a large, fast missile designed to engage targets at long range before the launching aircraft enters the threat envelope of its target's defensive systems. What the Iranian engineers had added through a decade of modification work at facilities in Isfahan and Tehran was a home-on-jam capability, a guidance mode that allowed the missile's seeker to track the electronic emissions of a surface ship's radar and ride those emissions to the target. A capability that turned the Lake Erie's greatest sensor advantage, the Spy-1B phased array radar that gave her the most capable air surveillance picture of any ship in the region, into a targeting beacon for the weapon coming at her. At 3:19 a.m., the Lake Erie's electronic warfare system detected 2 aircraft departing Bandar Abbas Air Base on a southward heading. Not at altitude, low, below 5,000 feet, a profile that was inconsistent with a routine patrol or a transit and consistent with a crew that wanted to stay below the radar horizon of a surface ship for as long as possible before committing to an attack profile. The EW system identified the aircraft as F-14 class within 22 seconds of initial detection, based on the radar emission profile of the AWG-9 fire control system, a signature so well characterized in the threat library that the confidence rating was 91% before the second radar sweep confirmed it. The TOW had the aircraft tracked, and a threat assessment computed by 3:20 a.m. The geometry was the problem. 2 F-14s at low altitude closing from the north at a range that placed them outside the standard missile engagement envelope for the first several minutes of their approach. The SPY-1B was painting them in sufficient resolution for tracking but not yet for fire control quality designation. The Fakor-90s published maximum range, a figure that the intelligence community assessed as likely conservative, meant that the Lake Erie was potentially inside the weapon's engagement envelope before her own missiles could reach the launching aircraft. It was the geometry that the F-14's designers had intended, refined and updated by Iranian engineers for a different weapon, a different era, and a different target. The TAO made his first critical decision at 3:20 a.m. He reduced the SPY-1B's emission power by 60%, shifting the radar to a low probability of intercept mode that maintained air search capability at reduced range, but significantly decreased the electromagnetic signature that the Fakor-90's home-on-jam mode could track. The reduction in radar power degraded the fire control quality on the inbound aircraft. It also degraded the track quality on the convoy, which had been the Lake Erie's operational focus for 11 hours. He made the trade without hesitation, because a degraded track on a cargo dhow was a recoverable situation and a Fakor-90 impact was not. The F-14s detected the reduction in the Spy-1B's emissions at 3:44 a.m. and adjusted their approach profile. The aircraft separated, one continuing south at low altitude, the other climbing to medium altitude on a diverging bearing. The separation was a tactical choice that forced the Lake Erie's fire control system to manage 2 simultaneous threat tracks on diverging vectors, splitting the tracking and engagement resources that had been concentrated on the original 2-ship formation. It was the kind of adaptive tactical decision that the Hollywood rules of engagement described accurately. An adversary that was watching, thinking, and responding to the defensive actions taken against it. At 3:22 a.m., the low-altitude F-14 launched 2 Fakor-90 missiles from a range that the fire control system computed as outside the standard missile's reliable engagement envelope by 11 kilometers. Not impossible, not optimal. The high-altitude F-14 launched 1 missile 14 seconds later from its diverging bearing, creating a third inbound track on a different approach vector that the engagement sequencing system was simultaneously trying to prioritize against the 2 weapons already in flight. 3 Fakor-90 missiles, 1 ship, The Lake Erie fired 3 SM-2 Block 3s in immediate succession, committing to long-range intercept attempts that consumed significant defensive depth in exchange for the possibility of defeating the threats before they reached their terminal guidance phase. The fire control team worked the engagement with the focused, compressed efficiency of people who understand that every second of hesitation at this range adds meters to the terminal engagement geometry that cannot be recovered. The first SM-2 launched on a ballistic arc toward the lead F-14, its seeker acquiring the target at long range on the uplink guided intercept vector that the SPY-1B was computing in real time through its degraded power mode. The intercept quality was marginal. The reduced radar power was producing tracking solutions that carried higher uncertainty than normal. But the TAO had no better option. He was working with the sensors he had configured for survivability, not for fire control optimization. The first intercept missed. The F-14's home on jam seeker had detected the SPY-1B's emission reduction and had shifted to its inertial plus data link guidance mode for the mid-course phase, receiving targeting updates from the launch aircraft through a data link that the Lake Erie's EW suite was attempting to characterize and jam. The characterization was still in progress when the second F-14 reached its terminal guidance transition point. The second SM-2 achieved a partial intercept. Detonation within the lethal radius, but at an angle that produced fragment impacts on the F-14's airframe rather than a direct hit on the guidance or propulsion section. The missile continued. Its aerodynamic behavior changed. A slight instability in its flight profile that the fire control system detected as a deviation from the predicted terminal guidance path. The deviation was not large. The F-14 was wounded, not defeated. It was still homing. The third SM-2 was committed to the high-altitude aircraft's missile, while the Phalanx system was tasked with the terminal defense of the two surviving threats from the low-altitude launch. The CIWS engaged the lead F-14 at a range of 900 meters. The weapon detonated in the engagement. Not a clean kill, but a structural failure of the airframe that caused the warhead to detonate approximately 40 meters off the Lake Erie's starboard bow. The pressure wave from the detonation struck the hull as a sharp lateral shock that rang the ship like a bell, and was felt by every person aboard as a physical force transmitted upward through the deck plates and into their bodies. The partially damaged second F-14 was inside the Phalanx engagement envelope when the first weapon detonated. The CIWS reacquired and fired. 2 bursts. The first burst impacted the airframe. The second burst reached the warhead section at a range of 240 meters. The detonation at 240 meters was categorically different from the detonation at 40 meters. The pressure wave arrived with a force that the ship's designers had not fully anticipated at that range geometry. Not because they had underestimated the weapon's warhead, but because the angle of arrival placed the overpressure load directly against the forward engineering plant ventilation intakes on the starboard side of the ship. The ventilation intakes were not primary structural members. They were service penetrations in the hull side plating, protected by storm baffles and intake screens designed to exclude seawater during heavy weather. The overpressure wave from the warhead detonation at 240 meters drove through those baffles with a force that the storm baffle design standard had not included in its load cases. The forward engineering plant took a pressure pulse through its ventilation system at 3:24 a.m. The pulse traveled through the intake ducting and reached the heat exchangers for the number 1 and number 2 gas turbine generators. The cooling systems that manage the thermal load of the generators providing primary electrical power to the Aegis combat system. The pressure pulse was not sufficient to rupture the heat exchanger cores. It was sufficient to displace the coolant flow through both units simultaneously, creating a momentary vapor lock condition in the coolant lines that caused both heat exchangers to register a high temperature alarm in the same second. The generator protection systems responded as designed. Both generators tripped offline to prevent damage from the thermal anomaly. The Lake Erie lost primary electrical power to the Aegis combat system at 3:24:07 a.m. The SPY-1B radar went dark. The fire control system lost its uplink to the third SM-2 still in flight toward the high-altitude F-14s missile. The SM-2 without guidance defaulted to its onboard terminal seeker and continued on its last computed intercept vector. A degraded engagement mode that produced a miss by a margin that the post-engagement analysis would calculate as 31 meters. The Fokker 90 from the high-altitude aircraft continued on its approach, now tracking on the reduced but still present electromagnetic signature of the Lake Erie's backup radar systems, which were running on emergency battery power and operating at a fraction of their normal emission level. The engineering officer of the watch had been at his station in the central control station since the F-14 contact was reported. He understood from the nature of the electrical event and the simultaneous trip of both forward generators that the cause was not a standard mechanical failure. Standard failures do not take two generators offline in the same second. He bypassed the automated restart sequence, which required a 15-minute cooldown cycle that was not available, and initiated a manual purge of the coolant lines in both heat exchanger units simultaneously. Using the emergency bypass valves that could restore coolant flow without completing the full startup sequence, by accepting a reduced cooling capacity that would protect the generators from thermal damage only if the electrical load on them was managed within specific limits. The purge took 4 minutes and 20 seconds. During those 4 minutes and 20 seconds, the Aegis combat system ran on its emergency battery reserve. The battery reserve was designed for exactly this scenario. Not indefinitely, but for long enough to allow a controlled restart of the primary power source if the crew executed the restart without delay. The crew executed without delay at 3:27 a.m. with the emergency battery reserve at 41%. The number 1 generator completed its manual restart sequence and came back online. The Aegis combat system began its power restoration handshake at 3:27:08 a.m. The SPY-1B radar completed its restart sequence at 3:27:44 a.m. The air picture rebuilt itself in the time it takes to draw a breath. The Fokker 90 from the high-altitude aircraft was at a range of 6 kilometers and closing. The Phalanx had been tracking the inbound track on its independent power circuit throughout the blackout. It had not been able to engage at long range. The CIWS engagement envelope against a supersonic inbound was limited by the weapon's maximum effective range. But it had been maintaining its track, updating its fire control solution, and waiting for the moment that the inbound entered its engagement zone. That moment arrived at 3:27:51 a.m., 7 seconds after the SPY-1B came back online. The CIWS fired at a range of 1,200 meters. The engagement was not clean. The Fokker 90's angle of approach placed it in the CIWS's nominal engagement geometry, but at the boundary of the system's maximum elevation angle, requiring the mount to track at a rate that put it at the edge of its mechanical slew limit. The first burst impacted the airframe. The weapon pitched downward, its guidance disrupted, and it impacted the water 108 meters off the starboard bow in a column of spray that rose and fell in the darkness. The 2 F-14s had already turned north before the third Fokker 90 was neutralized. They were not going to re-engage. Their missile load was expended. Their mission had been to prevent the interdiction of the convoy, and the 3 minutes of combat had consumed every weapon they carried. The convoy was still on the water. The Lake Erie began her approach to the convoy at 3:41 a.m., 17 minutes after the engagement ended, with the number 2 generator still in its manual restart cooldown sequence and the ship operating on single-generator electrical power. The SPY-1B was running at reduced capacity to manage the power budget. The boarding teams were staged in the well deck. The operations officer had revised the boarding sequence to account for reduced sensor coverage and communicated the revision to the boarding team leaders in the flat, informative tone that good operations officers use when the mission has changed. But the mission continues. At 3:41 a.m., with the engagement complete and the air picture showing no further threat signatures from the direction of Bandar Abbas, the TAO authorized the restoration of the SPY-1B to full power and began the process of rebuilding the surface picture that the preceding 22 minutes of combat operations had fragmented. The convoy had not scattered. It was still in its compressed formation, still on its reduced speed track, still behaving like a formation that had been told to hold and had held, even through an engagement that its crews had certainly monitored on their own passive equipment. The intelligence interpretation of that behavior was straightforward. The convoy had been instructed to maintain its position and had complied, which meant that the instructions it was receiving came from a source that had sufficient confidence in the air escort to expect the interdiction to be defeated. That confidence had not been rewarded, but it had been close enough that the operations officer noted the assessment in his log before he moved on to the boarding sequence. The first boarding team reached the lead dhow at 4:22 a.m. The cargo hold contained what the intelligence package had described: guidance system components, sealed in foam-lined transit cases with manufacturing markings that the forensic team would spend the following 48 hours documenting. 41 cases. The second and third vessels were boarded without resistance. The fishing vessels carrying the balance of the cargo were directed to a holding position and boarded in sequence by 5:47 a.m. The entire cargo was accounted for by 6:03 a.m. The Lake Erie began her transit to the logistics support ship at 6:15 a.m. The number 2 generator was restored to normal operation at 6:44 a.m. The ventilation intake baffles on the starboard forward hull required replacement from the ship's repair stock, a 4-hour task completed by the damage control team while the ship was underway. The heat exchanger units were inspected and cleared by the engineering team. No permanent damage to the cooling system was identified. The pressure pulse had stressed the equipment without breaking it, and the manual purge procedure had prevented the thermal damage that would have required a shipyard repair. Here are the numbers when the manifest is complete and the cargo is aboard. 2 Iranian F-14s launched from Bandar Abbas at 3:19 a.m. 3 Fakur 90 missiles fired across 3 separate engagement tracks. 11 kilometers, the range deficit of the SM-2 at the moment of launch. 4 minutes 20 seconds. The manual cooldown purge that restored primary power. 41%. The emergency battery reserve remaining when the generator came back online. 7 seconds between SPY-1B restart and final Phalanx engagement. 108 meters. Closest impact to the hull. 41 cargo cases recovered from the convoy. 0 fatal outcomes among the crew of the Lake Erie. The mission was completed. The F-14 crews who flew that mission understood their geometry precisely. They had placed their aircraft at a range that they calculated would keep them outside the Standard Missile's reliable engagement envelope. They had launched a weapon with a guidance mode designed to defeat the specific countermeasure that the Lake Erie had employed. They had forced a generator trip that took the most capable radar in the region offline at the moment it was most needed. They had come within 7 seconds of making that trip matter. What closed those 7 seconds was an engineering officer who bypassed a 15-minute procedure with a 4-minute alternative that he had practiced, and an emergency battery system that had been designed, specified, procured, and maintained by people who had anticipated exactly this scenario and had built in enough margin for the crew to use it. 7 seconds is not luck. 7 seconds is the accumulated product of every decision, every maintenance cycle, and every training evolution that had ever been applied to that ship and that crew before 3:24 a.m. The ocean does not record what was prevented, only what crossed it safely.